Imagine a situation where a machine operator is complaining that a motor was occasionally shutting down at the start of their shift. The events behind this type of problem may be random in nature and difficult to capture. In order to ascertain why the machine is shutting down, we'd have to capture multiple parameters at the instant it shuts down in order to diagnose the root of the failure. For this situation, we're going to be measuring the output of the 3 phases as well as the current draw through the circuit. In this test, we'll use the same connections to measure the voltage on phase A, phase B, and phase C. We'll also connect a current probe to the 4th input to measure the current at the startup of the event. Let's turn on the 4th channel so we can display the current. In order to capture the waveforms on the 4 inputs at the startup sequence of the machine, we'll go in and use the oscilloscope in the scope record mode. The scope record mode will capture the high-resolution digitized waveform over an extended period of time. It can capture an event of recorded waveforms for as long as 24 hours. To simulate the startup sequence, I'm going to power up the demo board, capturing the 4 waveforms during the startup. Once you captured the event, press stop, and then go into the normal mode. Scroll across to the beginning of the record to the startup sequence to find and analyze the waveform for any anomalies that may have occurred. What you'll notice in this instance is the input D, which has the current on the phase, saw a transient potentially causing the machine to go into overcurrent mode and shut down before it was able to completely start up. Continuing to scroll down the record, you can see what happens on each of the phases at the moment the voltage comes live. You can see the voltage on input A, B, and C, and then the current coming for D as it's starting to build up into the sine wave. Here is where you'll inspect the sine wave or the waveforms for potential anomalies.